Stoichiometry Part 1, the mole. Stoichiometry is the word for chemical calculations, figuring out amounts of materials which will react in a chemical reaction. But before we can do calculations, we need a concept called the mole, not a small furry creature that lives underground. Recall that atoms are made of protons, neutrons, and electrons, with the nucleus of protons and neutrons having the majority of the mass. Recall also that atoms are extremely small, too small to count. The atomic mass listed on the periodic table is a relative quantity. It is not measured by itself, but found by comparing elements to each other. Atomic masses were first calculated by assuming hydrogen had a mass of 1. The masses of other elements were calculated by measuring mass ratios of compounds, which included hydrogen. Oxygen has also been used as the reference element, and now the reference element is carbon-12, a specific isotope of carbon. Note that atomic masses don't have measurable units. They are simply stated with no unit, or the term atomic mass units, or just units are used. Given what we now know about the particles that make up atoms, one atomic mass unit can be defined as the mass of one proton or one neutron, which, while they are not exactly the same mass, are close enough in mass for our purposes. 1 mole can be defined as the number of nuclear particles, protons or neutrons, needed to weigh 1 gram. This is a very large number, 6.02 times 10 to the 23rd. This number, 1 mole, or Avogadro's number, is simply a unit for counting things, very small things. Think of it like a dozen. It is just a name for a particular number. It happens to be a very large number. A mole of water drops would be the volume of all the oceans. A mole of avocados would be the volume of the earth. A mole of any element has a mass numerically equal to the atomic mass, but in grams. So a mole of hydrogen atoms has a mass of 1.01 grams. A mole of carbon has a mass of 12.01 grams. And a mole of copper has a mass of 63.55 grams. This makes sense if you think about what gives atoms their mass: protons and neutrons, and the number of protons and neutrons in each type of atom. The most common isotope of hydrogen has 1 proton. A mole of protons weighs 1 gram, so a mole of hydrogen atoms also weighs 1 gram. The most common isotope of carbon has 6 protons and 6 neutrons, for a total of 12 nuclear particles. Protons and neutrons have the same mass, or close enough for our purposes. So a mole of carbon has 6 moles of protons. Each atom has 6 protons. And 6 moles of neutrons, for a total of 12 moles of nuclear particles. 1 mole of nuclear particles has a mass of 1 gram, so 12 moles of nuclear particles has a mass of 12 grams. Zinc has 3 common isotopes, and several others which make up less than 5% of the total. When the weighted average of the isotopes is calculated, a mole of zinc has a mass of 65.38 grams. In summary, atomic mass is a relative, rather than measured, quantity. Atomic mass is expressed in atomic mass units, or just units. Atomic masses are relative to the carbon-12 isotope. 1 atomic mass unit is about the mass of a single nuclear particle, a proton or a neutron. 1 mole is the number of nuclear particles needed to make 1 gram. A mole is just a number, like a dozen. It's just a very large number, 6.02 times 10 to the 23rd. A mole of any element has a mass in grams numerically equivalent to that element's atomic mass as listed on the periodic table.